Hello everyone, welcome second year students English section, Faculty of Commerce, Salat City University. This is Reem Sobhi. I'm a teaching assistant at Insurance Statistics and Mathematics Department, and this is the online sections of Mathematics of Finance course, Part 2, Compound Interest. In this section, we will discuss Chapter 8 titled Perpetuities. In the last section, we defined perpetuities and we clarified that we have two types of perpetuities, ordinary perpetuity and perpetuity deo. In this section, we will clarify and define another type of perpetuity, which is the deferred perpetuity. And this is a special case of the perpetuity, as sometimes the perpetuity can be deferred for a certain period, and after this period, the person can start the payment of the perpetuity. So this is now, and we have a deferment period. This is the deferment period, and then after this period, the person or anyone can start the payment of the perpetuity. Here is the perpetuity till infinity. So in this type of perpetuities, we have to get the present value of these perpetuities now. So we have two types of the deferred perpetuity: ordinary deferred perpetuity and deferred perpetuity deo. The present value of an ordinary deferred perpetuity equals A infinity deferred equals R over I times 1 plus I power minus F, and F is the number of deferment periods. The present value of the deferred perpetuity deo equals R over I times 1 plus I times 1 plus I power minus F, and again minus F equals to the number of the deferment period. Let's take some examples to clarify the idea of the deferment of the deferred perpetuity. Example 1. What is the present value of a perpetuity of $3,500 is made at the end of 6 months and is deferred 2 years if money is worth 8.5% compounded semi-annually? So in this example, it's asking you about the present value of a perpetuity with value $3,500. So this is R, and this perpetuity is made at the end of each 6 months. So this is an ordinary perpetuity, and it's made each 6 months, means twice a year, so M equals 2. If this perpetuity is deferred for 2 years, so we can draw our example. This is now, and this is the deferment period, and this equals to 2 years. Then after this deferment period, we start by paying the perpetuity for infinity, and we need the present value of these perpetuities. So these perpetuities are deferred for 2 years, and the deferment periods here, and as it's converted semi-annually, so F equals to 2 times 2, so F equals 4. If money is worth 8.5%, this is J, and compounded semi-annually, so I equals J over M. Again, from this example, J equals to 8.5%, M equals 2, as this perpetuity is made at the end of each 6 months. So this means twice a year, so m equals 2. And I is j over m, so this is I, and n is infinity as it's a perpetuity. F equals 4 because the deferment period is 2 years, and this is the deferment period. And the perpetuity is made twice a year, each 6 months. So 2 by 2 equals 4. 2 times 2 equals 4. He is asking about the present value for this deferred ordinary and perpetuity. So A infinity deferred equals R over I times 1 plus I power minus F. And by substituting values, R equals $3,500 over I times 1 plus I, the power of minus 4, and this equals to the present value of this deferred ordinary annuity. Again, another example. What is the present value of a perpetuity due of $4,500? So this is the value of the perpetuity. This is R, and the first payment is to be made after 1 year. So it's deferred for a year. This is the deferment period. And if money is worth 6% converted monthly, so this is J, and as it's converted monthly means M equals to 12 and I equals to J over M. And F here, which is the deferment period or the number of a deferment period, means 1 year, the deferment period, times 12 as it's converted monthly. So F equals to 12. So again, from this example, J equals 6%, M equals to 12, I equals J over M, and N infinity as it's a perpetuity, and F equals to 12. 1 year of deferment times 12 as it's converted monthly. This means F equals to 12. And by substituting these values in the formula of the present of deferred perpetuity due, the present value of deferred perpetuity due, this equals to A infinity deferred equals R over I times 1 plus I times 1 plus I power minus F. So 4,500 over I times 1 plus I times 1 plus I power minus 12, which is F. This equals to the present value of the deferred perpetuity due. Example 3, $95,000 is the present value of perpetuities made at the end of each 6 months and is deferred 3 years. If money is worth 12% compounded semi-annually, find the value of the perpetuity. So 95,000 is the present value of the perpetuities. So this is A infinity, as this is the present value of the perpetuities. And the perpetuities are made at the end of each 6 months. So it's made twice a year. So M equals 2. And these perpetuities are deferred 3 years. So there is a deferment period equals to 3 years. And as the perpetuity is made twice a year, so F equals to 3 years times 2, this equals to 6. So we have 6 deferment periods. If money is worth 12% and compounded semi-annually, so this is J, find the value of the perpetuity. So he is asking you about R, which is the value of the perpetuity. And as the perpetuity is made at the end of each 6 years, so this is A infinity deferred And from this example, we get J equals to 12%, M equals to 2, I equals J over M, so it's a 6%, N equals to infinity, and F equals to 6. Again, the present value of a deferred perpetuity, and this perpetuity is made at the end, so it's an ordinary one. So R over I times 1 plus I power minus F. This is the formula. And by substituting values in this formula, we have the present value of these perpetuities, these deferred ordinary perpetuities, and this equals to $95,000. And R is missing. I equals to 6% times 2, 1 plus I power minus 6. So by multiplying the present value, or 95,000 times I, which is 6%, over this value, we get R, which equals to this amount. Example 4, $200,000 is the present value of perpetuities made at the beginning. So this is the present value, but for a perpetuity due, not ordinary. And this perpetuity is made each month. So it's a monthly perpetuity, or monthly annuity, and is deferred for 1 year. So the deferment period is a year. So F equals to 1, which is the deferment period, times 12 as its monthly payment. If money is worth 12%, so this is J compounded monthly, so M equals to 12 and I equals to J over M. Find the value of perpetuity, which is the missing, and so he asking about R. From this example, we have J equals 12%, M equals 12, I equals 12% over 12 means 1%, and N equals to infinity, F equals to 12. Then by substituting these values in the formula of a deferred perpetuity due, we have this formula. So we have the present value of these perpetuities, which equals to $200,000, equals to R over I times 1 plus I times 1 plus I power minus F, which is 12. Then R equals to, again, by multiplying this value times I, and then dividing the result over this side, we get the value of R, which equals to this amount. And this is the value of the perpetuity deferred due, or deferred perpetuity due. Example 5, $25,000 is the present value of perpetuities made at the end of each 6 months with $1,500. Find the periodic rate of return. So in this example, he's giving you the present value of perpetuities. So this is A infinity. And these perpetuities are made at the end of each 6 months. So this is an ordinary perpetuity and made at each of 6 months. So twice a year. So M equals to 2. With $1,500, so this is R, and he's asking about the periodic rate of return, which is I. So we already have A infinity, M equals to 2, R 1,500, and N equals to infinity. And as this is an ordinary perpetuity, so A infinity equals to R over I. And we have the value of A infinity, which is $25,000, and the value of R equals to 1500. So he's asking about I. So I equals to R over A, I equals to R over A infinity. And this equals to 6%. So the periodic rate of return is 6%. Thank you for watching this video. Hope it's useful to you. See you at the next video. Good luck and goodbye.